Powerfilm are an Iowa-based manufacturer of flexible, thin-film solar panels that provide custom solar products for industrial, consumer, and military remote power applications. First, the solar material must be produced.
The basic roll processing, where we make the core solar module, begins with a roll of plastic, a very thin roll. Tends to be somewhere around 30 microns thick and maybe 1,000 feet long. That roll goes through a sequence of deposition machines to put down first a back metal contact, followed by the semiconductor amorphous silicon, actually 6 layers of amorphous silicon, which makes the solar cell itself. That's the part that absorbs the light and turns it into electricity. And then a top conductive layer that is also transparent, lets the light in, but also is conductive enough to bring the electricity out the front face. So you have the metal on the back, the transparent conductor on the front. That's where you get the power out.
From here, the film is then loaded onto a laser scribing machine. Here, the roll is unwound on a machine that uses laser heads to scribe the material into sections that begin to make up the individual solar cells on the roll. From here, the rolls are moved onto the printing stage. Electrical insulators are printed between the individual solar cells in order to isolate the positive and negative sections, as well as also being run through a silver print machine. The silver print machine prints conductive silver ink particles that increase electrical conductivity.
Once it's been tested, it goes through a process where a copper bus bar is put on, which is something we will solder to get the electrical connections later. Then a laminate is put on the front surface and the back surface, and that's usually a Teflon type product that is highly resistant to chemicals and water, moisture. It will protect the module from the environment.
The roll is then loaded into a die cutting machine. This machine unwinds the roll and die cuts it into individual modules which can be used in a variety of products. The die cut modules are then loaded into a machine that tests each module electrically, one at a time. The machine places each module onto a lighted surface and probes check electrical characteristics. The modules are then sorted into pass and fail bins. Passing modules are then loaded into a large machine called a pick and place. Here, a robotic arm picks up individual modules, checks them for orientation, and then places them onto a fabric surface. The robot keeps placing modules on a fabric in a pattern that has been determined by the computer. Once completed, a laser cuts the fabric piece, forming the outline of the foldable solar panel. Panels are taken from the pick and place station, and operators then string the modules together on the fabric body using a flexible, multi-stranded wire known as a Litz wire. The steps here include using a soldering iron to burn away small sections of lamination over the conductive tape. Multiple connections are made to ensure that the solar panels are still operational, even if a wire breaks.
Once that is all done, we will then run it through a lamination process, through a high heat lamination process, which helps bond everything together, helps reseal so that the moisture resistance is improved.
The panels are then moved to the sewing cell. Here, the edges of the panels are sewn. With the edges of the panels sewn, a top fabric wrap is added. Product labels are stitched on and strips are sewn over the wire attachment points. In the finishing cell, the operator adds a circuit board and connector. Grommets are added to the corners, which allows the user to strap down the panel in windy conditions. Completed units are then taken outdoors for a final test prior to packaging. Passing units are then packaged and moved to the shipping department in cases, ready to provide unlimited solar energy across the globe.